This computer. So today we're going to learn um, GitHub, and then if we have time, I'll do Python. I think we should do Python as well. Okay, I'm going to create a new diagram on draw.io. So now, so now that tool, right? Uh, Git flow. So what I'm teaching you guys is called Git flow. Okay, Git flow, meaning that we have some code, right? Um, this is me, Debo. I mean, not exactly, but this is Debo. And I have written some code on my laptop. All right, Terraform code, right? Laptop, right? All right, this is my Windows laptop. Windows laptop. All right, right there, boom. And on this laptop, what do I have? I have Terraform code. Uh, Terraform is not there. Okay, let's grab a Terraform icon. Architects, this is what you have to do, right? When you're designing diagrams, you have to go to Google and get the icon, Terraform icon, right? And you go to images, you grab that icon. Right. You always want a clear background. Always use a clear background. If you want to add an icon to your resume, like I did for your resumes, I just leaked the secret on the recording. Anyway, grab the one of these icons, right? This one looks nice. I'm gonna grab copy image and then take it to hide meeting. Hide this floating meeting controls. And then take it to here and paste it here. Control V. Paste here. Allow. Paste here. Hmm? Copy image and paste image. There we go. Right. So, and then you have your GitHub, right? I always like to draw things out before I go do them or explain, right? You have GitHub, which is a place where you store code. It's a code repository tool. GitHub is a code repository tool, right? So GitHub is what? You guessed it. GitHub is a server. GitHub is a code repository server. That's what it is. But it's an application, right? It's online. It's a website. So we access it to the website, to the internet, pretty much, right? So that's what GitHub is. That's it. Simple as that. So, right? As you know, this is a server, this is a client. This is a client, right? Because we are the client, right? Our laptop is a client. In this particular scenario, what's the client here? The client is what? VS Code. Yeah? That's why I have our code, right? VS Code is a client. So if you go look here, this is our code. All this code we've typed here, right? All this code we've typed here. Oh, cancel that. We want to move this code into Git. We want to save the code into Git because as you look at things right now, this code is on your personal laptop, but you're working for a company. How do you share this code with people? Are you going to email it to them? No. If you email it to them and then you make a change on the code, you're going to save the file and email it to them again? Hmm. Let me ask the question to the class. You don't have to know the answer. How do you share code during development process with your team? How would you share the code? All answers are correct.
Um, wait, what the to share information generally in companies, we usually use share folders or things like that. So now for IT, I don't know if it's still the same thing.
That is true. People who are non-technical still use SharePoint, still use email, still use chat, still use Google Drive. But guess what? I'm sorry, guys. All of you in this call right now, I've moved from non-technical to technical. So you have to know how to share code or share files in a way where when you update it, they automatically get the update. So if you want to share with me a PDF document or a diagram or some Word document or your resume, it will be smart for you not to send me the file via email. It will be smart for you to put it in a Google Drive link and then you share the link with me. So it's a live document in Google Drive. You open up the document in your Google Drive browser. Once you update it, it automatically saves. So when I go to that link, I'm seeing the most recent document. Okay, for code now, if we put the code in there, I will make changes. You'll see the updates, but we want to be able to put it in a server that is publicly as it can be publicly accessible or privately accessible by everyone, right? So that is what GitHub is. GitHub is a code repository server where everyone has an account. The company buys a subscription, like Geico or whatever company you work for, they're going to buy a subscription. They're going to own it. They're going to own their own server, a GitHub server, and they're going to create your account. You're going to log into GitHub. You're going to see projects when you log into GitHub, right? This is GitHub. You're going to see projects here. I'm going to go here. I show projects. This is my personal GitHub account, right? These are my projects. So let me jump right in. I don't have any project actually created by me. I don't have any project actually. I just have repositories. But you can create a new project, or you can call this projects. Or just create it. Hold on. What's it? Just gonna call the project. Give it SRE-2025. Create project. And now under this project now, we can now add an item, right? Like we can add a repository, add things on this project now. So add an item, and you can want to add a repository or create a new issue or add an item from an existing repository. Like I have this repos here, Avengers 21. There's nothing in there. I have a Terraform sample. I can add this item to that project. Let's see what else. Demo repo. Mm. Okay, so I have two items in there, and then I can just dismiss it. And then pretty much that's it, right? I can go back to this project now, and in this project, I can go ahead and create a repository. I can create a new repository, and I can put the repository, I can call it SRE-2025, make it public, right? Add a README file. A README file is a description file. Isabel, you like descriptions, right? You like READMEs. If you want to put READMEs in every repository, go ahead. They're going to love you for that. Because a README file is where you can write a long description about everything that you're doing in that code. It's a lot of work. I'm telling you, I'm an old school guy. I don't do READMEs or descriptions anymore. If you work with me, you have to understand what a variable is and all this. And you know, you can go Google it. I don't have time to be describing things, right? Most of us don't. Trust me. It's extra work. If you're bored, go ahead and write a README file. No one really cares, right? You can add it. It's just a file. It's just an empty document that you can go and add descriptions about the code that you're going to save in GitHub. You're going to say, oh, variables or TF holds variables files for da 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 da. US is 1A. We here we're doing this. We're creating a bucket. They're gonna love you for that. You're gonna, oh, you're perfect. Oh, she has the best code. Yay, we're gonna promote her. Nobody cares about promotion these days. Nobody cares. We just care about making money and going home. So, a git ignore file is a file that ignores some. If you don't want to, so if you look at this files here, right? We want to push this file to GitHub to save it so everyone can use it. But there's some files that we don't want to push to GitHub, right? For example, this Terraform state file, right? Because this file might have the actual name of our EC2 instance, the actual name of our S3 bucket. You see that? The actual name of our S3 bucket is devops-dev ts.debo. If the public knows our actual S3 bucket name, it's a security issue. So we want to ignore everything that has a TF state, .tf state. We want to ignore that. So when we go create when we go create, oh, what was that? A repository, we want to say add a git ignore template file. And we can come now, like I say Terraform files. So we're going to be ignoring certain files. Whatever we'll put in the git ignore file is going to be ignored. Whenever we'll do a push to GitHub, it's not going to push. License, you always choose none. But your company is going to buy one of these licenses, right? We're free. We're not going to. So, but your company will buy one of these licenses, right? But for you, it's free, right? And that's it. Create a repository. Come on, create a repository. Okay. And that's the repository is created. So that's the git ignore, that's the README file. Now, when you go, so you open the git ignore, you see that? TF state. So if you want TF state to be ignored, what do? You just go in here, you remove that star. It says code is read only. But if you want to edit it, you remove the star in front of that. So now TF state will be ignored, right? Everything that has TF state will be ignored. Will not be pushed to the GitHub repository. You remove that, right? Other files that you want to ignore, for example, this file right here, this Terraform log file, you don't want to push this to GitHub, right? This is irrelevant. This file is also a huge file as well. So you can just copy the name of the file, copy, and then you add it in that git ignore. In the interview, they're going to ask you if you want to avoid pushing certain files to Git, what would you do to avoid pushing some files to Git? The answer is using git ignore. That's all. If I were you, I'd write that down right now. How do you prevent sending some files to Git? Git ignore. That's all. Very easy answer. Okay? And then you save changes. Whenever you save changes in Git, you have to just give a message, right? So you see here, updated git ignore file with Terraform exception files. Commit direct to main branch, commit changes. And you saved it. Now, whenever I want to push anything to Git, it's going to ignore this file. It's not going to push this file, log file, tf state files. So these files, we can push everything to GitHub. These files are not going to go. But this file, let's see what the size of this file. What is the size of this file? How do you check file size in GitHub in VS Code? I don't care. Don't matter. Anyway, so we want to push code from here, right? From our laptop here to GitHub, like that, right? That's what we want to do. Yeah. And so for this to happen, we need to be able to go into GitHub, right? Create an account, which we have done. and then create a repository. And we're going to create something called SSH token. And then we're going to copy this SSH, right? So SSH access, sorry, not token, right? Access, right? And then here, we're going to create an SSH key, SSH key. An SSH key has two things, right? It has a public key and a private key. The public key acts like your password. Sorry. The public key acts like your username, while the private key is your password. Okay, I'm going to ask a question to the class. Which one is the username? Access key ID in AWS or secret access key? Which one is the username in AWS? Secret access key or access key ID?
Access key ID.
And then what is the secret key ID? Secret access key, the password.
It's like the password.
Correct. So we're going to create locally here, right? We're going to go in here. We're going to open up a new terminal. Let me close all these files. Close. And I'm pwd where I'm at. You always want to be in the directory. So Terraform backend, you do pwd. We're in here. So we want to go back one step behind. So we're going to do a cd the dot. And now we are in Terraform backend, right? So here is where we're going to create that key. We're going to create an SSH key here. That key will give us, SSH key will give us two keys, a public key and a private key. The private key remains in our laptop. The private key remains on our laptop. And then what do we put here? We're going to put the public key here. Public key. We're going to copy the public key from here. And attach that public key to our account. Let me put it here. Copy the public key and paste in our GitHub account. Spelling is horrible. That's how you know I'm getting old. When you start spelling wrongly like that, you know, like old age is coming. Right? So we're going to copy that public key. We're going to paste it in this our account here. How? We're going to go here, go into our profile. We're going to go to settings, not preview. Settings right here. All right, we're going to go down to SSH and GPG keys. We're going to, oh, I have one key, but I want to remove it, right? We're going to click on new SSH key. We're going to paste that key in here. And then we're going to add it. Then now, we're going to go now and download or clone that repository to our local machine. And since that key exists here, you'll be able to use that key and the password to now connect to the server. So pretty much the public key and the private key is the username and password. But the server only needs the public key for you to connect to it via SSH. Because the connection is initiated from our vscode or our laptop, right? You only need to, so the server needs to just verify the public key. The server will be like, hey, let me check your public key if it's correct to what I have. So when this guy sends the connection request to connect to the server, what does he send over? He sends a public key. The GitHub looks and say, oh, let me check if I have that public key. Okay, I have the public key. It's the same. So I'm gonna allow you to connect to me and save code or get code from me. So when you're trying to connect to it, what is it? A get request, right? And then when it connects it, a session begins. right? Your GitHub session begins. So let's go ahead and do that, right? So I've created an account already, and there's a document on this, right? I just sent a document about this, right? Um, it's here in the chat somewhere. Like I said, let me open up the document just so here you go. You guys understand. I love Medium, right? I love Medium, guys. Medium has the greatest articles ever. Everything you're looking for is on Medium.com. Medium.com is very, very good. You see, it's published in this 4 minutes, right? That's somebody verified it before it was published. You cannot just go publish stuff on Medium.com. No, that because it's a paid site. I pay, I think, $19 a year to use Medium.com. I have an account. Even I'm not signing, but I have an account. I can see content that people don't have account cannot see. All right, so that's a plus, I would say. Yeah. Um, yeah. Any questions so far on anything we've talked about? Any questions so far? No questions so far. Okay. So let's install Git Bash. I think we already have Git, right? If we check, let's check. Make sure I have Git. So we'll do Git, that's the version. We have Git. But if we do not have Git, what we're gonna do, we're gonna go to PowerShell and we're gonna install Git using what? Chocolate. So Choco install Git Bash, right? That's what we'll run. But we already have it installed, so um it's failing, right? Because we already installed it. So version Git Bash dash test version. Okay. Git dash test version. I just checked on this side. It's there. Git dash test version. I guess PowerShell doesn't like Linux commands. So now we have our repository here. Let me go back to the repository. Just gonna go back to SRE 2025. That's what we created. This is our repository. It's empty, right? How do we um push code to the repo? This is called remote. Okay. Let's first of all learn the terminology, right? This is a remote server. It's called remote. Okay, remote server. And then this is a local server. Guys, give me 1 second, please. I need to So this is a local server, this is a remote server. Because local is on your laptop, this is remote. Okay? So that's that. So create a repository here, right? We have a repository here. Repository. Repository just means like storage, right? Where you store code, right? And then we'll have our code here. So we want to take this code and put it in this repository in GitHub. One move this code here. So what are we going to do? So if you look here, this is like a folder, right? What you see, this is like a folder, right? This SRE25 is like this is our repository. It's like something like a folder. You can go and add a file in here manually, like add file and create new file, upload files. So you can still go upload files and choose files and go to Terraform right? Back end, and then add the file like this. But this is not the right way to do it. This is using the UI. This is using the UI. This is using the console, so to speak. But as you're aware, on the job, we don't use console. We're going to use Linux commands. That's why I was singling for you from the very beginning. Everything that you're going to do on your job, Terraform, Git, Python, comes down to Linux commands. I'm going to cancel that. So we're not going to do this method. No, we're going to do it using the command line. So I'm going to go back here to the code. So if you want to add code, there's two ways you can do. You can clone this repository. Clone means bring this remote repository into our local machine here. That's what clone means. So I'm going to cd back into documents. So if I'm into documents, when I go now and I clone this repository, there's three ways I can do it. I can clone it using HTTPS. This method is only advisable when you want to save the code locally on your laptop and you don't plan to push it back to GitHub. That's what this method is preferable for. Okay. This method is the one that you're going to use. This is what everyone uses in the industry because this SSH method means you want to save this folder on your local machine, add code to that folder or to the repository on your local machine, and then you push the repository back to this remote server. So pretty much you want to download or clone, the word is clone, want to clone this repository, which is like download this repository or to your local machine, right? And then you want to add code into the empty folder or repository. When you download it on your local machine, it will show up here as a repository. However, it's a local repository, but it's still a repository, right? And then now, when you now add your code, we're going to drag files and drag and drop files into the folder called SRE 2025. Then we can now do a push and push it back to GitHub. When you download this repository, you will see a folder called SRE 2025. Let me show you right now. If I just do a clone, simple clone using HTTPS, I'm going to copy this file. I'm going to go here. This is a command. This is a Git command. Git clone. And I paste that link I just copied. And I hit enter. It's going to clone everything online to a folder. If we do an ls-ltr, you're going to see a folder called SRE 2025. So a repository is actually a folder. But in technical terms, it's called a repository because that's how we store code. But it's actually a folder, online, an online folder pretty much. That's what it really is. Okay? Cool. So, but that's not the way we're going to do it. So I want to go to remove that folder. How do you remove a folder in Linux? How do you delete a folder in Linux? What's the command?
-r.
Not complete. In the complete code line. What is it? RM dash what?
You want which file you want to remove exactly?
I
SR.
want the folder. I didn't say file. Folder.
Okay, RM-R. The name of the file.
Okay. SRE dash. What am I supposed to do next? Tell me. Kwasi, we're doing the command, right? What am I supposed to do next?
Basically remove right protected regular file. I don't get what this is here.
Yes.
Yes, oh yes.
Not working. It's protected. The file
Okay.
is right protected. It's a protected file. What did I say when I said when download the repository? It's a repository, right? It's protected. You cannot just delete it like that. So how do you delete? How do you delete a file that's protected or folder that's protected? How do you delete a folder that's protected? Oh my God! Come on, guys. How do you delete a folder in Linux?
rm-rf. Hold on there.
Lulu is a senior engineer. Guys, these things are things that you should know now. Like, I don't know if you stop practicing your Linux because you think you really know Linux, but you don't know, it will come in handy. You don't know Linux. I can tell you that. You don't know Linux. Okay, anyway, ls-lt. I'm saying because I do this every day. I practice this every day. I've been doing it for so many years, but I still do it every day. Because if I don't do it, you forget it. If I were you, I'll spend 20 minutes a day, 25 minutes maximum, just doing some Linux practice. Just doing it. IT is a continuous thing. Right now, you don't have a job. So if you stop practicing, you're going to forget. We're not going to keep having class forever. You're applying to jobs, but you also need to practice what you already learned. You need to revise. You need to prepare for your final exam. Like, this is not college, this is real life. You need to continue practicing Terraform, practicing creating instances, AMIs, S3. Whatever you want to do, you feel like you haven't done in a long time, do it because you're going to forget. You're going to forget if you don't practice it. I'm telling you, you can watch all my videos you want, but if you don't practice it, you're going to forget. Okay, clear my screen. So one little SSH. Let's set up the SSH, right? Let's go set up the SSH right now. Let's do the gitmedium.com. Where is the article? I think it's here. Right here. So we have Git bash installed. So now check out if the SSH key already exists or not. Open Git bash and run this command. This is the command now to check if there's an SSH key that already exists. Copy that command and go here. And I'm gonna run this command. I'm gonna paste it. Okay. So I can go to this folder called this folder here, .ssh. I'm gonna go to cd. If you want to go to any folder that is hidden in Linux, any folder that in Linux is hidden, I don't know how to get there, right? Don't know the path to get there to that folder. Because this is a file. This is a file, right? Oh, sorry, a folder, actually, it's a folder, it's a hidden folder. You don't know how to get to this hidden folder, you can just do this command, this key here. Tilde is on your keyboard, is next to letter 1. Next to 1 on the left of 1. So it's shift and then shift and then you press it. So tilde /.ssh. It will take you to that folder. Hold on. Why is it not showing me that folder? Maybe we don't have it. This is a brand new laptop. Maybe I don't have a .ssh folder. Yep, I don't have it. It doesn't exist. So when I go and create it, I was gonna create. I don't have it. It's the first time. Maybe you guys will not have it because you're never created. So it's the first time. So we don't have it. Great. So now I'm gonna go ahead and if ID RSA is a private key pair that is used to sign and authenticate connection, remote host, RPOP is a public key. So here is a command, SSH keygen -t, and I'll explain what this command means. I'm gonna copy this. I'm gonna paste here. So now we're gonna create SSH key. pwd. I can see it back into documents. So I'm there, clear screen. So I'm gonna paste that command. SSH-keygen -t type. T stands for type. So what type of SSH keys do we want? We want an RSA key. There are many different types of keys. There are many different types of keys that you can use. You have OpenSSL, you have ED keys, you have POP keys, different type of keys. But we want to use the RSA type of keys. The private key will look like this, ID underscore RSA. That's a private key. That remains on our laptop. The public key will look like this, ID underscore RSA.pub. That's what we'll copy. the content of the private key and take it to GitHub and paste it in GitHub. Under SSH GPG keys, we're going to paste it there. And then we're going to synchronize everything, and then we'll make a connection to try to connect from local machine to GitHub. That's it, done. So here's a command, but I'm going to tweak it a little bit. This is my email address, right? The email address that was used to create your GitHub account. So this is mine. So the SSH key gen means generate key. The type of key we want is an RSA -B. Actually, I don't want to do -B. I want to do a -O. Hold on. I didn't cram the command of head. I'm going to do SSH -key gen -T -O for OpenSSL. -T is RSA -O and then -C. This is the one I want. I don't want that other command because I want to give the simplest commands possible. You can also use PuTTY as well, but I want to use this particular one. No, where is it? I think it's Linux. Yes, this is it. So this is it. Yeah, OpenSSL gen key gen. Okay, that's it. Yeah. So that's it. So I'm gonna do a -C -O and then -C, that's my email address, and then enter. Actually, it failed because there's something here, -O, -O, -O for OpenSSL. That's T is here. You guys see O anywhere? O option, there it is. Option right here. So the option can be ED 25519, right? It's one of the options. And then -T is RSA, and then option is add to. So these are different types that exist, or different options that exist, right? You see here. So let's do that. Let's run that command again, but this time I'm going to do open, just keep it very simple. SSH execution -T RSA is this done. And we're going to generate a key. Enter file in which to save the key. So we don't want to save it. Sorry, we don't want to put any file name. We'll just leave leave it the default name. So it's going to be in C, users, user, SSH ID, and that's it. Enter. Enter a passphrase, no passphrase, enter. And that's it. It's saved. So now if you now cd into tilde.ssh, you now go there and in ls-ltr, you now see this is your private key and this is your public key, right? Now what we want to copy, according to our diagram, right? We want to copy the public key and put it in our GitHub account. So we're going to go, how do you look at the public key? In Linux, the command is called cat. You don't want to open the file. You want to just look at the file without opening the file. You don't have to do VI on every file. You can see the content of a file without opening the file. The command is called cat. So we're going to cat ID underscore RSA dot pub. And that's the key. We're going to copy everything from SSH Be careful when copying private keys. One of my coworker copied a key and forget one letter. They forgot the M, like that, and then we're having errors for 4 days. Until I went and checked and said that, oh, he didn't copy it correctly. So he didn't apologize for it, but it was his fault that he didn't copy it correctly. So be very careful. So here is our account. We're gonna go into settings, SSH and GPG keys. New SSH. I have an old one there since 2020, but I'm not gonna worry about it. Right. New key. I'm gonna call this SRE-2025. Authentication type is authentication key. Don't do signing key. Authentication key is when you want to use SSH to connect. Signing key is for something else. Okay. And you see here, the keys begin with SSH.RSA or etc. These are the different types of things, right? So we're going to paste that in here. You see, this is the key, SSH.RSA, and my email is there. Okay, and I'm going to add SSH key. And that's it. It's added. That is there. The SHA-256. It's a unique ID. So whenever I try to connect now from my VS Code to GitHub, what it will check, what? It will make sure that this ID is unique and both parties, the server and the client, have that SHA-256, that public key. That's what you will check. Because I've taken the public key that I have locally here and I've put it in my GitHub account. So they both, this server and local machine, they both have the same public key now. I've given it with him. So now when I come and connect with him, now he will say, hey, let me check the connection. Oh, okay, your key is correct. I'm going to let you in. Any questions so far before I continue? That's how we connect to GitHub. Any questions? No? No questions? Okay. So we have connected the key. Now we want to do what we just discussed before. Go back to the repository. Go back to GitHub. This is the repository. And what we want to do is SSH. So we're going to click here. We're going to clone using SSH, right? So that we can, because now that we have a SSH connection between our local machine and Git, we can now push code back and forth between the two. So we're going to copy this right here, copy the URL. And now we're going to go to our VS Code. We're going to clear our screen, go back to documents. So just cd.dot/documents. So in documents. And I'm going to clear my screen. I'm going to do a git clone. And I'm going to paste that URL. No, this looks like a git, hold on, the SSH one, the HTTPS one. Be careful, right? There's HTTPS, which has the HTTPS and the URL like this, and there's SSH. You always want the SSH one, which is git@github.com, then the username and then the key. So this is the one I want. So I'm going to copy that, and I'm going to paste here. And I'm going to clone it. The authenticity of github.com, this is the IP address, can be established. 825 key fingerprint is in 825519 key fingerprint is in this. So this key, remember this key, this SHA-256? Remember that SHA-256 that we saw here? Let me go back there. Remember this SHA-256, this one? And in KQ? right? This one, this server, this local machine has its own SHA-256. That's their own unique identifier. So now this local repository we're going to download here has its own, right? Every SSH key has its own because of the private key. This is the private unique identifier, not the public one. Private. So this key is not known by any other names. Are you sure you want to continue connecting? Yes. I will not connect it. If you're not going out to ls-ltr, you'll now see this repository. So now we'll now cd now into SRE. We are now inside of Git. You see that's changed to main. You see? Let me go back out. It's not there. If you go into Terraform backend, there's no main attached to it because it's not a repository. It's a normal folder on our laptop. But if I go back out to documents and I go into SRE, it's a repository. That's how you know because you see the main here, the main branch. Repositories have something called branches. This is the main branch in the repository. I'm not going to go into the detail about branching. I'm going to skip it very simple for today. But how do you know it's a repository local on your machine? You see this word in bracket called main. So now here you can do a git, you can do a ls-ltr. There's no files in there, but your readme. Oh, look at that readme. You can do a cat and you can do a readme to see what's in your readme file. It's empty. There's nothing in your readme file. That's it. You're now in an empty repository. Now, what you can do to start is what? You can now go to documents. It's an easy way. And you can just copy this file, this folder, sorry. You copy this folder, or just drag it and drop it in here. Just the file. Let's open another program. Okay, let's open another program. We can just drop this one in here. And that's it. They want us to close this file out. So we're going to go in here and we're going to open folder. I'm going to open SRE25. Boom. Look at that. Yes, I trust the authors. Look at that. Boom. Open up a new terminal. Look at that. Boom. That's our git ignore. Remember that git ignore we saw on our repository? Yes. That git ignore file. Remember? We opened up tf state T and Terraform lock. Remember? That's the git ignore file. That's it. That's our readme file. So you have a readme file called SI25. Isabel can come in and start saying, this is our Terraform code we did in class during our training. Just some stuff, and you can save the file. And then you have AWS, this is all of our code in there. Now we can go back now to we can now add Terraform backend in here as well. And that's it. We come here now, we have two folders, Terraform backend and Terraform AWS. Like that. Yeah? Okay. Cool. So now we have files in here. I added some files in that folder. In our folder locally here. All right. Take note of what's going to happen. When you add files in Git in your repository locally, this is your local repository, right? The first command you want to check is what? Git status. Git status tells you what has been added or what has been modified. Look at this. On the main branch, you have modified a README file. It's showing you red because you have modified it, but you haven't saved it. Yes, you saved the file on your local machine. You saved it. But according to the repository, you're not tracking it. You haven't saved it according to them. It's not staged for commit. It's not ready to be pushed, pretty much. Let me put it that way. Yes, you have saved the file on your local laptop, but it's not ready to be pushed to Git. It's not ready to push. To push it to Git, we have to do some other things before we can push it over to Git. Yes? Yes? Are we there? Yes? No? Maybe?
Yes, yes.
Okay. I want to make sure I'm not losing you guys. So I make sure you know. So Git status we have some files, right? And then now that we have some file, now that for us to be able to push these files, make it ready to push. So it's Git status, and then it's Git. We're gonna commit the files now. When you see it changes to say but not committed, right? So we're gonna do a Git add star. Git add dot means that everything that we've added to this file, everything that we added to the folder, is in the folder, but it's not tracked. We're not tracking it. The repository is unaware of it. Because think about this, right? Here, right here in your SI 2025, it's empty. This repository that is empty or this folder is empty is also linked to this folder. But in the local folder, you have added some files in here. So guess what? This local repository on your laptop is ahead of the remote server because there's no files in here, but there are files in here. And because this repository that you see here in your remote server is linked to the local repository through what? Through what? What's the link through? SSH. SSH is linked to SSH. So whatever changes you're making here locally can affect the remote server because they're now linked via SSH. So you need to be careful when making changes directly inside of a repository locally on your machine. These are the commands you will run in this order. Git status to see what you have added, if it has been staged or is been tracked. The next thing is add, git add dot. Dot means add everything. Also, you have a question? Git
No,
add,
no.
git add dot means add everything. If I wanted to add only one thing, if I wanted to add only Terraform AWS, I will say git add Terraform dash AWS. Add only that folder. So I will type. I'll hit enter and it will say, oh, I spelled something wrong. Terraform. Man, it's time for me to retire, man. I'm spelling wrongly these days. Git add Terraform. Warning. In the working copy of Terraform, this L will be replaced by Z the next time Git touches it. That's just some warning is giving you because of what? TF state. It's supposed to be ignored in this ignore file, right? So it's giving you that warning. So now, if you do a Git status again, Git status will always tell you what's going on. Look at that. Terraform AWS was added. It's ready to be committed, means ready to be pushed, ready to be saved according to the repository. Saving it locally on machine is saving it. Commit means saving it into the repository. So we have added Terraform AWS, but we haven't committed it. We haven't done a commit yet. There are two files that have not been added. Sorry, one file not been added and one has not been committed. So this one, we can also add this one as well. So we can do a git add. Or we can just do git add dot, and it'll add everything. That's it. It adds everything, right? Now, if you do a git status again, I love git status. Git status will save you a lot, guys. Git status will save you a lot. Now everything is added. Now it's ready to be committed. So git status is what you run. Then git add dot adds everything. Then now you run a git commit, which is now saving the files in your local repository. Once you save the files in local repository, then you're able to now push to your remote repository, which is Git Online, which is this here. So we have to save it first in the local repository, and the process of saving in your local repository is called a git commit. So we have to commit it first. So git commit -m, M means give it a message. Whenever you commit files, you have to give it a message. You have to tell people what you're doing. Isabel, git commit. What are you pushing to the repository? Git commit, I'm going to put it in double quotes, pushing Terraform AWS code. That's my commit statement. That's a phrase. Enter. Please tell me who you are. Okay, we need to enable to. It wants us to enable this Git global configuration. So you want us to log in. So let me do that. At Gmail. Okay, and then my username is I am Debo365. Okay, so now when you decide to go ahead and do a git commit, which is saving it in the repository, that's why you see access to login, right? Because they are now saving it into the repository now, right? The local repository -m for message, adding Terraform AWS code. All right, and commit. You see, 14 files changed, insertions, 1 deletion to the various files that have been committed. Now we're gonna do a git push to push it to here. So it'll appear here, and the command is git push origin main. I believe that's the command. And that's it. So it means we're pushing code, and the code is coming from the origin, the main branch. That's what this command means. That's it. And when you come here now and you refresh this, you now see your files in there. That's it. That's the push process. That's pushing code to GitHub. Now, Kwasi can now go to my code or to this code and download the code now and use it. How does Kwasi do that? If I wanted to go back here, let's say someone has added let's go add some stuff here. Let's go into this folder and add a new file. Let's upload some new file here. Let's choose a file. I want to just show you how the difference between the two will be, right? Documents. Let's use this diagram. And we're going to commit changes. We're going to give it a message. Added diagram. The painful thing with GitHub is that you always have to give a message, and your message has to always be descriptive. So people like me who don't like to write descriptions or tags, or I don't like this kind of things, I struggle with it. But that's why I became an architect, right? I don't have to do this every day. You have to commit change, right? You're saving it, right? It's processing the file. Imagine you're uploading 200 files to the Git. It's gonna take forever. So that's how we do command line. So now this local repository is now behind. Before, when we do a Git push, they were all on the same page, right? But now I've added one more file here. So this guy is ahead. This guy is behind. If we do a Git status here, it says, oh, everything is up to date. We're good. But no, it's not. It's not. Because this repository, remote repository, is ahead. It has one extra file called gitflow.io. While here, if you look here in this folder, it doesn't have that file. So the first thing you do when you come to work in the morning, let's say you're doing development. You have to develop an application for 6 months, and you're doing development work. That's what you do every day. Before you go home, you do a Git push to save your code in GitHub, right? You always do a Git push, especially if you're working with an offshore team. Offshore team is in the Indian, right? If you're working with an Indian team, so at 5 p.m. you get off work, you do a Git push, you put a message, leave some notes in the Git push. In your commit message, you write right here when you do the commit, right? You put a message, add entire code, version 2, whatever, in your commit file. In your description file, you explain everything in there clearly. You go home. When you go home at night, they come to work in the morning, they log in, they're working. They update the code. When you come in and work in the morning, whatever you have locally on your laptop is out of date. You need to update your stuff locally here before you start developing because they have done some work, they've created some code, they've added some files. But when they added some files, they pushed it to what? Git. They pushed it to here. So you're not going to come again and go here and clone it again. No, 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 you're not going to do this step. No. This step is done once and only once. Because you already have a connection between your local machine and the remote repository, all you have to come in the morning and do is Git pull. That's it. Done. It downloads all the stuff from the internet, which was what? One file. That's it. Git flow .io. That's it. That was the only thing that was added. And this file has what? 65 lines, 65 characters, sorry, in it. That's it. One file change, 65 insertions. That's it. Done. Let me do it again. I'm going to add one more file again here. This time let's add it into Terraform backend folder. Add file, upload file on local machine. Let's do some music, the pictures. There's no pictures in here. Oh, is that me? Huh. I'm wearing a Liverpool jersey. We won the Champions League and then all everything. Uploaded picture. Commit changes. And that's it. Now, if you do a Git status again here, he's good. He's up to date. But no, he's not. He's up to date locally. Here. Locally here, he's up to date. On main branch, he's up to date. But here, it's ahead by one file. So what do we do when we come in the morning or want to update our local repository? Git pull. And that's it. One file, that's the image. And now we do Git status. We're good. Now we can go here and add a new file and call this file main.tf. And we'll call this file, this is our, I'm just going to call this file. I'm going to save this as a simple resource, AWS underscore instance, just some simple code. And I'm going to call this dev dash EC2 and then AMI. I'm going to just leave it empty. Leave it empty and instance type. My spelling is in danger. instance underscore type equal to. Leave it empty. Save it. So we have a new file here. Look at that. No, Siri, I'm not talking to you. I have a new file here. See? The U appears untracked. Means that the repository doesn't know about this file. If you come and do a git status, untracked files, main.tf. So what do we do to add this file to the repository? What's the command?
Git add.
Git add what?
Git add the name of a file or main.tf.
Git
Main.tf.
add main.tf. That's it. What next do I do? After you add the file to the repository, what else do you do next?
Git status.
Yes. Quasi has got it already. See, it's added. After that, what next? Git commit -m. -m means message. Added main.tf. I said ft, main.tf for EC2. And then what? Git push origin. Whatever branch is here. Sometimes you may have a dev branch, means development branch. Main is the main branch where all the code is stored. But sometimes you're not ready to put the code in main. You want to put it in dev and then fix it when it's good and you put it in main. So if you have dev appearing here, right here, you do git push origin dev. But since we have main here, we're going to do git push origin main. Origin means where is the code coming from? You can do a git push from any branch. You can have multiple branches here. Okay, I can do a git branch dev. It creates a dev branch. You can do a git switch dev. It switched to dev branch now. If I do a git status, there's nothing in this branch. All my work is saved in the main branch. This is how we separate environments. Dev, test, UAT, production. Developers develop in the dev branch, and then they have a meeting, review the code in the meeting, and when it's good, then you now push to the main branch. Everything we've done so far is in the main branch, not in the dev branch. Dev branch is empty right now. If I want to go back now to my main branch, I go back to a git switch main. I'm back to my main branch. Git status. Everything is ready for commitment. Git push origin main. Remember, there's one new file, main.tf, that is not here. It's not appearing here. Everything is, right? It's not here. So we want to see a main.tf file appear here. I want to refresh this. There's nothing there. But when I come here and do a git push, origin main, I push that one file. I'm gonna come back here and refresh it. That's the file. If someone goes and add a file here without your knowledge, when you come in the morning, you do a git pull, and that's it. And that's Git. That's all of Git. Very easy, right? That's it. It's over. Now you can just go study interview questions of, okay, how do you push a file? How do you switch branches? The command line. Guess what? I have a cheat sheet for you guys. I have a cheat sheet for you guys. But you must know some commands though. You must know some commands off head. Git status is one of them. They'll ask you, you push some code into Git and something failed. How do you check Git status? The guy asked me that question again. I just said Git status. It's like, man, oh yeah, answer Git status. I'm like, yes. Git status, man. In Linux, how do you check CPU consumption? In Linux, how do you check CPU consumption?
Top comment.
Okay. It's in the top of your head, eh? I'm looking for the cheat sheet to give you guys. Git cheat sheet. This is the Git cheat sheet. When I put files in the chat, do you guys get it? Are you able to get it? Yes? No?
Yes.
Yes? Okay. I'm gonna put the Git cheat sheet in the command, not command, the cheat sheet. It has all the commands. I'm putting in the chat right now, okay? 1 second. It should be coming in through in 10, 9. My laptop is slow. I need to restart it. Man, it hasn't been going for restart in like 2 months. And here is the, oh, I have a Terraform cheat sheet. Wow. I have cheat sheet for everything. I have a Linux cheat sheet. I have an Ansible cheat sheet. I have a Terraform cheat sheet. I have a Docker cheat sheet. Man. Do you guys want me to just email to you guys all the cheat sheets? Yes? I can just email everything in one email.
Yes, please.
Yes.
Okay. But let me put the Git right now so we can study some stuff. I'll email you the rest of it. I wanted to just when I type cheat sheet, all the cheat sheets popped up. I'm like, damn. I have a lot of cheat sheet. Linux cheat sheet, Kubernetes cheat sheet. Man. 1, 2, 3, 4, 5 cheat sheets. Man, it's a lot of cheat sheets. Well, I just put it in the chat. Everything is in the chat. Kubernetes cheat sheet, Linux cheat sheet, Terraform cheat sheet, Git cheat sheet. It's all there. So let me share my screen and show you this cheat sheet. This is it. Where is it? Where is it? Here it is. You can see the commands, right? So to set it up, after you do the SSH key, you have to do the global username and email to validate these 2 commands, right? Then after that, you just do a git clone. And then this is what we did. We did a git, where is it? We did a git, a git push, a git pull, right? We did a git status. Where's status? Right here. Status. We did add a file, right? We did commits, and then give a descriptive message. Isabel, it's a description. When you commit your stage content as a new commit, give it a descriptive message. We did git branch, create a new branch. We did git branch. You can do a checkout. You can do a switch. If you want to see all the issues on it that are happening, if you want to look at issues, like you want to investigate what's happening, you do a git log. It will show you all your commits in the current branch history, right? Git log. And that's pretty much it there. Git is very easy. That's all. And then you want to update your local reports, you just do a git pull. That's all. Git is very easy. That's all. There's not too much to Git. We're done. We're done with Git. That's it. So if you guys want to set up your Git command, your Git environment while I'm here, we can do it together. I can stop recording. We can share screen and do it together, or you can watch the video and do it on your own. It's up to you. We're done with class today. Do you want to do Python, or we should just do Python on Wednesday? What do you guys think?
We can start now and finish on Wednesday.
The Python setup?
Mm-hmm.
Okay. Okay, let's begin Python setup now. We're done with Git. There's no charge for this, right? It's free. It's not AWS that charge you. This is free, right? I can just leave it like nothing will happen. It's free. There's no payment for this stuff. Clear my screen. Okay, let me stop sharing. Which screen do you guys see? Okay. So this is that screen. So Python setup. I gave you guys this medium.com document. You have it, right? This document. So Python setup. This is what we're going to Python setup. I hope I remember the steps. The steps, one is to go to python.org. and I'm going to download and install Python. Downloads. We're going to download Python 1.3.2. I'm going to install it. Run. This is very important. Please, please don't forget to check this box. Add python.exe to your path. When you do this, that means that you're saying that you want to be able to run Python from anywhere. Please, please do not forget this step. It's very, very important. It's super, 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 super important. Okay? So add python.exe to path. All right? And then use admin privileges when installing Python. That means that you want it to be able to install with admin privilege. So it will install in the whole laptop. Because sometimes when you install Python, it will just install only within your session. And then when you log out, it's gone. We want to install this permanently. So we need admin privileges to install this. We can install now. See that? I'm going to do this. And then, yes, I'm going to install Python. This is one way. This is the UI way. The command line way is what? Choco install. But I prefer this because Choco install sometimes doesn't use admin privileges to install things. Python is that weird programming language that when you want to install it, because it has so many libraries, and I'll explain what a library is, right? A library is just a library is a library. Like when you go to the library, you want to read a book about action movies, you go to what? The action movie section. So Python is a programming language and it has libraries for DevOps. It has libraries for monitoring. It has libraries for AWS. It has libraries for Google. It has libraries for Terraform. It had libraries for Docker, right? So a library is simply just a section of a programming language that you can use to do a specific task. If you wanted to do to check your code for syntax correction for Terraform, you will use PyTest, if I can pronounce, PyTerraTest, right? It's a Python library for Terraform. If you wanted to do DevOps, let's say you want to do monitoring Prometheus, you will use the Prometheus library for Python. If you wanted to build a web application for Python, some application, you want to build some application called, some application API, you use Flask. Flask is the programming language for Python. If you want to learn Python on your own, very easily, go to w3schools.com. This is it. You can learn any Python language for free, and I'll give you a certificate for free. Python, these are all the various things for Python. So the basics are here, from home all the way to here, file handling. That's where basics end. From here, you have the models. NumPy is a library for data sciences, for mathematics. Pandas is a library for data. SciPy is the library for data sciences. Django is used for web development. Matplotlib is used for charts and graphs. Machine learning libraries is what you have your scatterplot regression for building AI models. For databases, you have Python, MySQL. So you have I think it's called PyMySQL. For MongoDB, you have Python. Then you have the different Python reference as well. So you have different examples here. So the very many libraries, right? So for AWS, the Python library for AWS is called Boto3. It's called Boto3. That's the AWS library for Python. So if you're going to work in AWS, you may need to know some Bodo 3. Not too much, but some Bodo 3. In which cases would you need to use Bodo 3? S3 buckets, right? You have some code examples in here that you can use, right? Like I mentioned, S3 examples is a good one to start with, right? S3 buckets, creating S3 buckets. This is the code, right? So in Python, when you install Python on your laptop, you want to create some code in Terraform. The first thing you do is import. Import is just simply importing that library into your code. So in this case, I'm going to copy this, go to VS Code, open up a new file. I'm going to call this s3.py. You see, do you want to install the recommended Python extension for Microsoft for Python language? Can you install it? Yeah. So whatever code you write in VS Code will have the colorful Python stuff. Like in Terraform, we have autocomplete, right? And syntax highlighting. So in Python, you can install the Python extension as well. So whatever you type here will have those colorful things. And if you make any error, you report your error in problems. Extensions are good. It helps us make life easy, right? Because we don't know everything. We're not geniuses, right? But guess what? I added that file and see what happened. It added a U on tracks. Okay. So Kwasi, when you write many, many files, you write ec2.tf, ec2.tf, guess what you're going to see here? You. Until you do a git add before you disappear, okay? So here, I copied that code from the internet for S3 bucket creation. I'm going to paste it here. This is to create a bucket using Python. The first thing you want to import login. Why are you importing login? Login is a library, or a method. So let me back up. Python is a programming language. A library for AWS is called Boto3. In that library, you have methods. For example, Boto3 is a library, right? And then from Boto call exceptions, import client error. This is a method under Boto3. It's a method under Boto3. Login is a different Python library. Login Python package for Python is based on pep288 and comments into. So this is a login package for Python. It's a login library for Python. Whenever I want to log in Python, this is what you import. Another one, if you want to work with the operating system, let's say you want to copy files from your operating system from a local machine and save file, other stuff, you're going to import OS like that. OS is the operating system library. It lets you access like your underlying folders and stuff, right? And then what else? So this is a code to create an S3 bucket. It's a function. Define, def means define, you're defining a function. Create bucket, bucket name, region equals to none. So this creates an S3 bucket in a specified region. If a region is not specified, the bucket is created in the S3 bucket default region, which is US1. So as you know now, everything in AWS, the default region is US1. So this is the code. Try if region is empty. This is the code. If region is empty, S3 client, which is this local VS code, boto2.client, create bucket, bucket name. If the region is not empty, else boto3 region, use the region name and the location and create a bucket with a bucket name. If not, report an error and also log the error because we have the login library enabled, log the error, and then if it's successful, return true. If it fails, return false. That's the code to create a bucket. That's it. Very, very simple. You don't need to know how to write Python. You don't need to be a programmer. In an interview, they're going to ask you, what's your favorite programming language? You're going to say Python. You're going to say, what libraries do you know? You're going to say, I know AWS Boto3. They're going to say, okay, what have you done with AWS Boto3? You're going to say, I've created S3 buckets of Boto3. EC2 instance of Boto3. Oh, okay, cool. How do you get your code? I use the Boto3 documentation. I'm just showing you the code. I'm going to show you how to run the code now. Okay. I use the Boto3 documentation. I'm going to put this link in the chat. Okay. I use the Boto3 documentation. Who? That's it. Listing bucket. Look at that. You can list everything we've done with AWS CLI, you can do with Python. Everything we've done with Terraform, you can do with Python. That's it. EC2 examples right here. Boom. Managing EC2 instances. Describe instances. Remember? That's it. That's the code to describe instances. Everything is there. Anyway, we've installed Python. This is the installation. Now we want to set up the virtual environment. I want to just set up Python in here, right? We're gonna just run it from here, right? So we have that Python code, right? I need to save it first, right? And then, so now we want to do Python dash s version. You see, this is the problem with Python. We've installed it, but it's not coming up. So let's close everything and reopen. Yep, updating Visual Studio. You see that? It was updating it. You saw that? Did not open up on its own now. Okay. Let's open up a new browser. Python dash this version. Python was arguments. Okay, no, Python 3 actually. Hold on. Okay, let's see if it was installed with Choco. Install. Interesting. I wonder if that installation installed it. So Chocolate is installing Python now. Means the UI did not install it. Because I don't work with Windows, guys. I bought a Windows laptop just for you guys. I've never thought last using Windows. Never. I've always used Linux, my MacBook. But I went and bought a laptop a couple of weeks ago for you guys. A previous dependency failed. This is the issue with Python. Python is a big, that's why some people just use Conda, to be honest with you. Just like Choco, install Anaconda, but the short form is called Conda. Interesting. So let's see. Python 3 dash version. Python was not found. Run without arguments to install from the Microsoft Store or disable this shortcut from settings. Is Microsoft trying to ask us pay for it? Oh, I think something is wrong. I think I know what happened. Let's install it again. Uh, I think we're supposed to do something. I'm repairing it. Yeah, Python was not installed. Come on. Yeah, Python is a pain. Uh, repair was successful. Okay, let's see. Oh, Microsoft wants us to install it from the App Store. Microsoft is selling Python now? Huh. I guess this is new. I didn't know this. I mean, do you guys have Microsoft Store on your laptops? On Windows? Yes? Kwasi, you have this Microsoft App Store? They're trying to
No.
they're trying to copy Apple App Store. Interesting. This is the first time I'm seeing this. Okay, it's installed. What else? Okay, Python. And now it's installed. When you type Python, it opens up a Python browser, and now you can run that file, right? You can run Python s3.py, but it fails because, hold on, we are not in the correct location. Exit. Or you can just run it from here. ls-ltr. You can just run Python and then the file name s3.py, and that's it. It will run. But we don't have the Bodo3 module installed, right? We don't have the Python SDK module installed. So um, if you wanted to do that, you go to extensions and you can run AWS. Um, you can just install Bodo 3. Bodo 3. That's it. Bodo 3. Trust publisher and install, yes. Okay, it's done. So you can now run the same thing again. Line number 2. Line number 2. Hold on. Line number 2. Line number 2. Import Bodo 3. You see this like here? It can give you ideas, right? So I'm going to figure out the issues with Python on Windows because this is new to me, right? I use Python on Windows, oh, sorry, on Linux. But anyway, so let's not even worry about running code. Let's just focus about installing it, right? So we've installed Python. If we do Python dash version, that's it. Boom. So it means I had to install it from the store, from the Microsoft App Store. So if you struggle to install it, go to the Microsoft App Store and get it from there. Looks like Microsoft is now protecting the installations. They want you to go to the App Store. I don't know if they have an App Store. I don't know about Apple Store. But yeah. We're way above time. Oh my God. So now that you have this, that's pretty much it. You have installed Python. That's it. All you have to do now is write code and run it, right? Um, you can come and create a new file here and just say hello.py, and you can just come and say, like a simple hello world example. Very, very basic. Like I said, there's some lot of stuff here that you can start, right? You can copy this simple line here and just say print hello world, and you can paste it in here, and you can save that file. And then here you just run Python and hello.py, and it prints hello world. That's it. That's Python. That's it. Any questions? We are done, guys. Wednesday is Ash Wednesday. I may go to church during the day or I may go in the afternoon. I'm not sure. Um, but any questions, guys? We're done.